Hello, good afternoon, good morning, and good evening, wherever you are in this world. I want to thank Yugabyte for holding this distributed SQL summit. I think it's a very amazing area of modern data platforms, as we'll see today. Today, I'll be talking about developing enterprise consciousness. And what does that mean? Well, if you can dream big, think of a single data platform that connects to all your applications, and it's connecting different business applications together. And some may say that's a data modernization project, or some may say that's a data transformation project. And what you'll see is that it's a little bit of all of those things. But developing enterprise consciousness is really about a mindset. It's a dream to seek so that the business effectively does a better job for its customers and for its employees. A bit about where I work. We help platform owners basically build big real-time data platforms that are for a global customer base that want everything right now, and they're everywhere. And that takes some heavy lifting, and that requires distributed data platforms. Well, the way we do that is we have a playbook, which is we're going to show a little bit of later on today. It has principles for designing, building, and managing platforms at scale. The goal is for people to be able to simply implement these principles and achieve basically the same type of scale as some of the largest companies in the world. We've helped quite a few of our customers, and a lot of the early work we did was with customer experiences and portals, although we focused primarily on data and analytics platforms. Our experience in customer experience platforms helps us understand the customer challenge, which is to have a great customer journey, whatever it may be. And that actually is, generally where the challenging, goals come to businesses. It's in marketing, and marketing being, the way to get customers to have a digital experience. Well, marketing technology itself is very complicated, and that's just a starting point. All modern technology is disconnected, and it's hard to integrate together. Businesses, they just want to create value, get the customer, deliver the value, and get paid. It doesn't matter if you're a street vendor in New York City or whether you are a multinational social network. This challenge has been there in business forever, and it only gets worse as more and more applications are created, and they all have different APIs, and all the data is in different places. So what do we do about the users? Most users, they just want to find things through whatever interface. They want to be able to find things quickly. They want to be able to analyze or visualize or measure, and then they need to act on that information. That information is no good unless they can do something with it. So if you are a driver for a logistics company, that information comes to you in real time. You're able to act on it on real time. Or if you're a user that's being told that a driver is coming to pick you up, or a delivery person is coming to drop off some food, it would be good to know if they're a few minutes away so you can go downstairs and open the door. So that type of experience actually can translate to a lot of other work loads as well, not just for customers using digital experiences from a business, but also employees having a better experience of the business as a whole. And the dream for enterprise consciousness is to have people, processes, information, and systems all connected, all synchronized, so that the work happens seamlessly, that the whole business is actually a platform of processes that are happening on it magically. And there are lots of amazing volumes on how to transform a business into a business platform, or how to look at the platform business model. And that's not what I'm talking about here. Every business has a digital technology business platform. And every business has some sort of customer experience, some sort of employee experience. They may or may not have things connected to their business. They may or may not have partners which they are connected to digitally. And more mature a company is, the more systems or platforms they have. But every business has a digital technology business platform. Whether or not you call it that, it is what it is. And the dream is to make one platform of all the platforms connected seamlessly together. And for us, the starting point was really looking at something like the Reactive Manifesto or the 12-factor app. And these are great. You can Google them, and the links are in the document whenever we get that posted. The 12-factor app is a list of 12 factors that make a SaaS application, a software as a service application, successful. If you're going to make a new SaaS application, you just follow these rules. The Reactive Manifesto, actually, I think, builds a lot on the 12-factor principles, and it's about how to make resilient, reactive, message-driven, maintainable platforms. And the key is reactive, in that it reacts to the demand of the user, or in our case, the demand of any users across employee or customer experience. And that unified experience for whatever, the customer or the user inside the company, like an employee or a vendor, a lot of times they have to jump from system to system to system. And what I mean by unified user experience, what I'm really talking about is having one view to the things that a person needs to do their job without having to jump across different systems. And of course, the idea of a portal has been around for a while, and that's not really what it solves a problem. Having the technology to show information is different from actually bringing the information in. So the challenge isn't on making the user experience. The challenge is making sure the data is updated in real time. And we can go beyond that. We can think about the right data is saved on the right type of hardware, so that we're saving money. That we're able to be redundant and always available, so that if there's a failure, we can always come back gracefully, hopefully with no downtime. And essentially, the challenges that we're talking about are a holy grail to solve, which is a business platform that never goes down. It's always scalable. It's easy to use, right? Everybody wants that. And you know what? I'm not going to sugarcoat it. It's not something that can happen tomorrow for any business today, even with the best technologies out there. It takes a little bit of effort. Current platforms, and I'm not just talking about legacy platforms, but current distributed data platforms, they have their own challenges in a growing enterprise. And this is every enterprise challenge, which is to go through phases of maturity while trying to create a data platform that serves the business's needs. Right? You don't want to necessarily create waste as the business is growing. This is a slide. Love this picture. It's a diagram from a book called Enterprise Architecture as Strategy, creating a foundation for business execution. It's a Harvard Business Review book, and one of my favorite books of all time, in that, for my career at least, really helped me understand businesses and what they do with technology and why they do it. What this really talks about is a business gets started, they start to create apps, or they start to buy applications. It used to be people ran these in data centers before, in their office, or co-located servers. Nowadays, they tend to put it on the cloud, or they're basically doing a SaaS subscription to a company like Salesforce or QuickBooks.com, and that's great. All that works until it doesn't. And so what companies have to do is they have to standardize the technologies they're working with. They may standardize on a particular protocol, like an API layer all needs to be in REST, or an API layer all needs to be in gRPC. Only then is it possible to even come to an optimized core, which includes standardized enterprise processes and standardized data. And that is kind of where our company helps with challenges, is getting between having some standard technology to coming to an optimized core. Or sometimes they have a lot of silos and they need help creating standards and on their way to having an optimized core. Once a company has an optimized core, then they have standard interfaces, and the business is kind of like a platform. And initiatives can get started, companies can be bought, and these things can be integrated in the overall data system very seamlessly. And if we go beyond that, we're thinking about business to business integration, making that easier for expansion in the market. But if you don't do these things in order, you have to go back and redo it. And it's like a marathon, right? You can't run mile number 26.2 until you run mile number 1. Here's a quick and dirty example, which probably doesn't apply to large companies, but it may. Let's say a company is using software, QuickBooks and Google Drive and WordPress, and they're using some combination of hosted applications and some subscription applications. And then what they decide as a standardization is to put everything on Docker. Right? Everything, it doesn't matter if we're using Java or .NET or Python or Node, it doesn't matter, let's just use Docker. Maybe Kubernetes isn't quite what they need yet. Maybe Docker is it. And then the optimized core is maybe they standardize on a particular database. Maybe they said, you know what, we're using SQL, but we're using MySQL and Oracle and Postgres, and let's just use Postgres. It's not good news for Oracle, but let's just use Postgres. And after that, the business is able to have one data platform essentially to get information in and out of. And that allows new initiatives to get started. So, for example, if the company, the marketing department requires a new marketing automation tool, or the sales department wants a new sales automation tool, that acquisition of that software to use in the company becomes part of a larger system, and the data can be then synchronized to that system as needed. And we'll talk about data synchronization a little bit later. So this is a diagram of a generic data platform. Today, they all kind of do the same thing. Businesses think that they're very, very unique. And what they do for customers and whatnot, sure, they're unique. But when it comes to the data platforms, they all kind of have the same components. Data comes in through various sources. Data goes out through various sources. There's some mix of processing engines, and there are different ways to manage the data inside. No good system these days will have just one type of database. They will have a relational database, they may have a non-relational database, they may have a data warehouse, they may have a data lake, you name it. If a company is worth its weight, it's big enough, they tend to have different types of databases. Some of them are for customers and digital experience, and some of them for internal IT and operations. And the data, this technology business has been the same, I think, for forever. I'm not that old, but for the last 20, 30 years, I've been playing around with technology. All IT is basically get data in a database and get data out. Right? It's nothing special. It's just the way we do it is slightly different. Well, we can make a leap from this design to something a little bit which I would say when I first learned about this next concept, it really changed my mind about how to help customers scale their businesses. I used to think about databases and data platforms in one way, but after being introduced to this concept, it blew my mind, and I started to think about companies and data platforms in a different way. In that area of platform design that I'm talking about is real-time distributed data platforms. This not just databases, but also you can think about distributed compute platforms, distributed stream platforms, and the cloud made it possible to make databases that can grow, but they had some limits, right? You can only have a Postgres database or a MySQL database that was so big, and then after that point, you had to replicate it, and there was a master-slave replication, but you just had this management nightmare to try to basically fit all this data into one computer, or to scale it, you had to copy all of the data. And the other databases that I had heard about, like HBase, for example, there was so much work involved just to run a simple database, so like forget it, right? But when we got real-time data platforms like Cassandra and Couchbase, where the big win that they brought for customers wasn't just the fact that it automatically sharded the data into different partitions. It also gave this concept of cross data center replication. So whether the data centers were in different regions of the world, or whether they were being used for different purposes, like in this diagram, one data center is used for reporting, another data center is used for transactions using APIs built in different languages, and another one is used for, let's say, machine learning. These data centers would keep data in sync, and that's amazing. It's like a Dropbox for business data, right? You put data into one place, it gets replicated to all the other places. And so this is, I think, one of the most fascinating innovations, at least in the open source world, that empowers so many big businesses and big business digital platforms today. The people don't really know, but this Cassandra technology has really changed the world. And that's great, right? But we're not talking about Cassandra today. A database that's built on the principles of Cassandra and has a Cassandra compliant layer, that allows us to go further. We're no longer limited to having data only available via CQL. We are no longer limited to, for example, having to do cross data center in two-way replication. We can have cross data center replication in a one-way fashion as well. And then obviously the technology being built in C++, it runs faster. It can store more data. But the biggest thing that Yugabyte brings to us is ACID. It brings us transactions. And in addition to having ACID, it gives us the resiliency of a system like Cassandra. Now, all that aside, when I think about Yugabyte, I take all that for granted because I've been dealing with this type of technology for a while. The thing that really makes Yugabyte a game changer, as compared to other distributed data platforms, is that it is a distributed SQL platform. It has a SQL layer on top of it. It has CQL, which makes it easy to lift and shift Cassandra workloads. But because it has a Postgres layer, it also makes it easy for adoption in businesses that have not used something like Cassandra. They haven't yet needed that type of scale. But the moment they bring Yugabyte into the picture, they're able to think big and basically get the best of both worlds. So let's say we have Yugabyte in an organization, and we want to bring data from different systems in. It used to be there was a lot of work involved to extract, translate, and load information. From a real-time perspective, we have ecosystems in Pulsar and Kafka, which are open source. But there are tools now that are low-code and no-code that allow the citizen data engineer basically to import data into a database using clicks, not code. That's a statement from Salesforce, right? Just clicks, not code. And that's a game changer if you have a database that has a Postgres compliant layer. you don't necessarily have to then filter all of the technologies that just work with, let's say, CQL for this kind of distributed database. So it opens up the connectivity between data engineering and data integration tools when you have the Postgres layer. So it's a lot easier to get data into Yugabyte now from other systems. Well, why would you want to do that? I already have data in there. Oops. Once it's there, you can, in a standard way, provide that information via APIs. And APIs that you don't have to create. Just by virtue of being in the Postgres ecosystem, technologies like Hasura or Postgres allow us to very quickly expose a REST API or a GraphQL API. In another data center, while the data is being loaded, while it's being served up in another data center, we can process and analyze using technologies like Spark. We can do batch processing on it, we can do deduping on it, we can do master data management at this layer. And if you wanted to, you can stream data out of this and process it in Flink or Spark streaming as well. Okay, that's great. So we've got data, we're kind of cleaning it up a little bit, we're doing some machine learning on it, and then we're giving that data to everybody. That's by itself, I would say, a big difference maker in many companies. Being able to take all the enterprise data that's there and provide it in a standard way and clean it in a standard place in real time without any delay is a big game changer. But wait, there's one more thing. Today, there's a thing called reverse ETL. And most reverse ETL tools, they work with SQL compliant databases or SQL compliant data warehouses. And what do you know? Postgres compliant databases work with a lot of these reverse ETL tools. What is reverse ETL? Reverse ETL is just the reverse of ETL, which is if you extract it from Salesforce and you did some transformation and you loaded it into Yugabyte and you made some corrections to data or you updated some customer information and you want to synchronize it back to Salesforce, you could either do that yourself through Kafka Connect, you process a stream and then send it via API. Or you could look into tools like Census and Rivery or Group.ru. Group.ru is open source, just like in the ETL deck, ETL slide, we had Airbyte. Group.ru is open source, and Group.ru and Group.ru and Airbyte are not the same company. But what makes this amazing is that when you put it all together, you have one data fabric where data is coming in one place, it's getting processed in another place, it's getting served up in another place. And by the way, the serving data center over here, it doesn't necessarily have to be read-only. You can accept writes to that information as well. And at the same time, we can synchronize data back to the source systems because, come on, even though you can find information in one place, doesn't mean that you're going to use some application that's different from the native application like Salesforce or Zoho or WordPress to edit your data. You're probably going to always want to go back to the source system to actually do the work, right? If you bought HubSpot or Salesforce for a reason, just because you could bring the data into your system doesn't necessarily obsolete Salesforce or HubSpot. They're useful in their own right. It's just that we've solved the data integration problem. But until we send the data back to Salesforce or HubSpot, we have to basically rely on a one-way data transfer. Now the data flows both ways. And in a relational database, unlike in a pure relational database that's not distributed, you couldn't necessarily do this all at the same time. You would reach some limit. And very few databases have the ability to segregate and separate workloads in this manner and scale. So if you're a company with 50 applications and data's coming in from 50 applications, data getting sent to 50 applications, and you may have millions of users, maybe not millions, if they're employees, maybe hundreds of thousands of employees using that information. It's going to put a toll on that database. How do we get there? Well, we have a playbook for this enterprise consciousness. There's a discovery process of people, process, information systems. There's a curated set of tools that work together, and we make recommendations. And then once you have the design, gotta get it. Usually with a no-code, low-code, it's an implementation, it's a configuration, clicks not code, but there may be some scripting involved, and maybe you know, you're not going to escape. There's maybe some programming involved, and because the framework dictates using automation to deploy everything and configure everything, ongoing administration is a lot easier. Only thing that operations folks have to do is keep the systems running, because users are basically doing all of the work, right? They're the ones bringing data in. They're the ones who are using APIs, and they're the ones that are then connecting it to then send data back. So the job of the platform administrators is just to keep it running, right? And let the users add more data as they will. And because Yugabyte is scalable, that's great. As more data comes in, we just add more nodes. Key takeaways for achieving enterprise consciousness: don't reinvent the wheel. I know so many companies that try to save money by reinventing something, and they end up actually spending more money. And there are other reasons why they don't buy things. But really, these days, it's a lot of stuff is open source. You don't need to reinvent it. Identifying the key objects, right? When we take a look at something like this, you don't necessarily want to synchronize every single object into a database like Yugabyte, right? You may put a lot of stuff into a data warehouse or a lot of stuff into a data lake house, but real-time data that needs to be synchronized, it's not for every object, right? So what may make sense for you? Customer profile, customer 360, client 360, patient. It's information that needs to be updated and synchronized, and not everything needs to be updated and synchronized. Use or buy ETL/ELT tools. Use or buy reverse ETL tools. This is a no-brainer now. There are a lot of things that are open source. But when you get data and you put it into a system like Yugabyte, remember, Yugabyte's purpose is to be real-time and always available. Not necessarily want to put archival data in there. There's better data formats like Parquet and Iceberg for that. And that's it. If you're interested in any of this stuff, you can go to our website. You'll find links to our YouTube channel and to our playbook. I'm really happy for Yugabyte and for DSS. I'm looking forward to the other talks. Thank you again, Yugabyte. Appreciate you having me.